Welcome to SanfordFlipMath, the home edition. This is Algebra 1. We are deep into quadratics. It doesn't feel like it's been quadratics for a while, but we've been doing a lot of factoring, a little bit of multiplying, and now the question that I have for you is, why all this factoring? I mean, honestly, what's the big deal? Why do we care about all this? Well, it actually ends up being a technique used very commonly for solving quadratics. Basically, there is a specific relationship numerically that happens that we are going to really use, we're going to exploit. So why all this factoring? Many polynomials or higher order equations, expressions come from things being multiplied, and that relationship will tie directly to graphing and a lot of the structures. So we are going to talk a bit about something called the zero product property. The zero product property says if a times b equals 0, then either a equals 0 or b equals 0. Yeah, so what? So in other words, if you have an equation that has some things that are being multiplied, and the answer to that is 0, then one of those two things being multiplied had to be 0. For instance, if I had 3 times x equals 0, and I want to solve that for x, doesn't x have to be 0? That's the only way you can get 0 as an answer for multiplication. So in other words, like if I had a couple of things being multiplied to equal 7, 1 times 7 equals 7, but there's actually other things, like for instance, 1/2 times 14 would be 7. 1/7 of 49 is 7. There are actually a million things you can multiply to get 7, but when you're multiplying to get 0, one of the things multiplied has to be 0. So again, just a quick recap, the zero product property, which is going to be the heart of everything we do after this for solving quadratics. The idea is, if I have two things that are multiplied to equal 0, either the first thing was 0 or the second thing was 0. Okay, and I just want to remind you the definition of a solution of an equation. Solution of an equation is the value that makes it true. Now, it is possible that there's more than one. It is the value or values that make the equation true, it being the equation. So the value or values that make the equation true. Now, when you see solve as an instruction, as directions, that means find all solutions. So not just one solution, but all of them. Now, if the equation only has one value that makes it true, then cool, you just find the one. But if there are multiple values that make it true, then you're supposed to find all of them. Okay? All right, so we're going to use factoring to solve quadratics. It's going to be based on the zero product property that says if you have things multiplied to equal 0, one of those things has to be 0. Look at that multiplication. That's why we factor. And what our goal is to find the values that make it true. Find all of the values that make it true. All right, so that sets the stage for what's going on. Now we're actually going to do some of that, okay? So this is what I call full service. I'm going to start you off with some stuff that's already factored. So the zero product property says that if two things are multiplied to equal 0, either the one thing was 0 or the other thing was 0. So here what I have are two things being multiplied equaling 0. So either the one thing was equal to 0 or the other thing was equal to 0. So literally what I do is I make two equations out of this, one from each factor. So x plus 3 could have been 0. The answer for this piece could have been 0. And if the answer for this piece was 0, then 0 times I don't care what this is going to be 0. Well, to find the x value, I'm going to solve this just like it was a little Algebra 1 equation. Now I can solve this one the same way. Now, because x can't be two things at the same time, we're going to write the word or in between them, because x can either be -3 or 5. These are both solutions. Now again, if they are solutions, that means they should make the equation true. So just as a quick little check, if I do -3 plus 3 times -3 minus 5, this would be 0 times -8. That is 0. That worked. If I do 5 plus 3, I'm just confirming that what I just did worked. 5 minus 5, this would be 8 times 0 equals 0. Yep, that worked also. So either way, I got 0. Okay, so the short version is each factor gets set equal to 0 and you solve it. You solve it like a little mini equation. Here I have two things that are being multiplied to equal 0. Well, either this thing was 0 or this thing was equal to 0. So I'm going to solve each of those. So -3 on both sides. So we're just doing some algebra 1 here. Some basic pre-algebra algebra. Divide by 2, divide by 2. So x equals -3 over 2. If you want to write that as a decimal, I'm okay with that. If you want to write that as a mixed number, I'm okay with that. -5, -5. X equals -5. I'm going to write the word or between them because x can't be both things at the same time. So again, we have two solutions. Whenever you have two factors, unless they're the same, you should expect to have two solutions. Okay, so here we are. X equals -1.5. 2 times -1.5 is -3. -3 plus 3 is 0. 0 times I don't care what that is would be 0. So -1.5 is a solution. -5, well, 2 times -5 would be -10, plus 3 is -7, times -5 plus 5 is 0. So -7 times 0 is 0. These work. Okay. This guy is not factored. Don't set x squared equal to 0 and -9 equal to 0. That doesn't even make sense. We have to make this into a multiplication problem. Well, some of you are looking at that. I hope you're saying, oh, dang, that one's an easy one. I remember that one. That one is a special pattern. So this is a perfect square. This is a perfect square. It's subtraction. So this is the difference of two squares. And if you remember, these factor into a plus minus thing. Now you could do plus minus or minus plus. And now this problem looks like these problems. Same kind of setup. So you set each factor equal to 0. Sorry, x plus 3 equals 0. Or x minus 3 equals 0. So solve each one of these separately. Okay, so again, this had two solutions. When you see x squared, expect two solutions, because x squared is something that should factor into two factors, and each factor gives you a solution. Okay, so plan on that. Okay, let's just do a couple more, and then we'll recap, and then we'll be out of here. Okay, so again, I see x squared, I expect two solutions. Okay, so the degree, the highest exponent for this thing is typically how many solutions you'll have. It doesn't always work that way because sometimes you have repeated solutions. Okay, so we're going to factor this. So I need, because of this negative, I know the signs are going to be different. If they are different, the bigger sign, the bigger number rather, will be negative because that guy's negative. And I need factors of -12, 1 times -12. So -12, and I need them to add up to -1. So it could have been 1 times -12, 2 times -6, 3 times -4, 4 times, yeah, okay, so we're repeating. Okay, so I'm adding now, and this is it, this is the one. Okay, so I'm gonna do a little box thing here. Now again, if you can see this without the box, I'm okay with that. Once we get into problems like number 5, my guess is you're gonna need the box. Okay, so this is -4 is the common factor here. Here is x. Here is just x. And here is 3. Now let me double check. 3 times -4 is -12. X times, okay, so it looks to me like my signs are working. So I'm going to say x minus 4, x plus 3. Okay, so based on those dimensions of the box. Okay, so this is the factoring that we've been doing now for weeks. Now we can use this to solve this equation. So set each factor equal to 0. You're going to say that factor could have been 0, or this factor could have been 0. Add 4. So x equals 4, or x equals -3. Okay, so those are the two solutions for this guy. Okay, I think we'll do maybe two more. I know I said a couple, but this one is pretty quick. So, all right. So again, is there a common factor? 3 doesn't go into 17, so I don't see a common factor here. So I'm going to be factoring it like this. Factors of 3 times -6 is -18. I need them to add to -17. This tells me the signs are different. The bigger one's negative. So I'm going to say like 1 times -18, 2 times -9, 3 times -6. 4 doesn't work, 5 doesn't work, 6, well, I already have 6. -7, okay, I guess we're done. Okay, so we found what we were looking for. 3x squared, -6, 1x, -18x. Just a 1 in common here. I see a 3x in common there, an x in common here, and a -6. -6 times 3, -6 times, yep, this is working. So 3x plus 1, x minus 6 equals 0. So if two things are multiplied to equal 0, then one of those had to be 0. I know I'm kind of cruising along here, and obviously you should feel very free to stop, pause, rewind, do what you got to do so that you're getting out of this what you need. Now, some people are like, yeah, I got this factoring thing, so move it along, and that's what I'm doing. You can hear me repeat things as many times as you wish, and that is all up to you. Now, worth noting, yes, a fraction can happen. So x can be either equal to -1/3 or 6 for this guy. Done with that, we're going to do one more. Okay. So is there a common factor here? Yes. So let's take that out first. I see an x in common. And so x times what is x squared? X times x. X times what is -2x. Okay. Just to confirm, x times x is x squared. X times a -2 would make a -2x. So yes, this did work. There's nothing else I can factor more, and I do have things that are multiplied to equal 0 here. So either x was 0 or x minus 2 was 0. Well, this is already solved. Okay, so we're done. 2 solutions for that quadratic. I expect that 2 second power, so I expect two zeros, 2 solutions. So just to recap, we are using factoring now to solve second degree equations. Quadratics, they're called because of the word quad relates to squared. That's why it's called quadratic. So you factor it. It must be equal to 0 before you start. Must be equal to 0 first, because it's based on the 0 product property, not the 7 product property or the 15 product property, the 0 product property. So it must be equal to 0. Then you factor. You set each factor equal to 0 and solve them separately. Okay, so that is the whole point of this lesson, and we'll be doing a lot of practice with this. But this is a big deal. This is a big deal in Algebra 1, in Algebra 2, and even in pre-calculus, and it gets used even after that. So these are all skills for the toolbox. All right, well, thanks for hanging with me on Sanford Flip Math, the home edition. It has been lovely. I want to say seeing you, but I'm not seeing you. And trust everything is going well. Bye.